All right. Welcome everyone to tonight's class, which is Drip Irrigation Fundamentals. And before we get going, we have Joe DiMaggio here from California American Water, and he is going to welcome us in. Take it away.
Me?
You.
Oh, sorry. Sorry, everyone. I have carpet cleaners at my house. They're about to leave. I know I'm announcing it to all these people. Okay. Anyway, on behalf of California American Water, the Water Awareness Committee, and the Monterey Peninsula Water Management District, we thank you so much for joining us this evening. And Marianne and Brent are going to teach us tonight about drip irrigation. So we're going to learn a lot of things. And I do want to say one thing, if you're a California American Water customer or you within the Monterey, the jurisdiction of the Monterey Peninsula Water Management District, on July 26th, I believe it's a Saturday, and we're going to be promoting this. We are going to be giving away free 2 truckloads of mulch or 6 or 7 bags of mulch at the landfill in Marina. So we have more to come on that. We have more classes still with Marianne and Brent, and so we'll let you know more further about it. And so we're going to be sending out email blasts. We'll be promoting it in the newspaper. So it's going to be a fun deal. Okay, everybody? All right. Thank you so much.
So the reason that these classes are sponsored by California American Water and the other sponsors is because when we look at the amount of water that is used in a residential setting, anywhere between 30 and 80% of that water is used outdoors. So yay, you take a 5-minute shower or you have a high efficiency dishwasher, but still there's such a large amount of water that is not only used, but oftentimes wasted in the landscape, that this is really where we want to focus our efforts. So for those of you who have been with us before, you will recognize the puzzle. It is how we navigate our classes, and it really serves as a reminder that everything is connected. So even though we're talking about drip, it is more than just about the equipment. So what we're going to cover tonight is remembering the basics. Puzzle piece number 2 is properly designing a drip system. 3, properly installing a drip system. For a few of you, I'm sure the question will be, well, how do I convert from a spray system to a drip system? We're going to spend a little bit of time on your controller, how you schedule it. And then the last piece of the puzzle is maintenance. So we've got a lot to cover in the next 60 or so minutes. All right, let us begin with a conversation about the watershed. So on the left, you have your conventional landscape, right? You've got turf, it's being watered with spray. The soil underneath it is probably pretty compacted, pretty depleted. We're not doing much to hold on to rain. Image on the right, this is what we aspire to. That's what almost all of these classes relate to, is how do we create a watershed-wise landscape? So it starts with the soil. Now, soil that is porous, holds on to rain or irrigation when we get it, releases it to the plants as they need it. As far as plants, we have diversity, we have density. Yes, there are natives, but it doesn't have to be exclusively so. We've contoured the land in order to hold on to rainwater. And when it comes to irrigation, we look at irrigation more as supplemental rather than the default. And drip is definitely one of the more efficient forms of irrigation. So that is why we are talking about that tonight. So even with what I talked about, holding on to rain, climate appropriate plants, improving the quality of our soil, there are going to be times when our gardens do need that extra water. The big question becomes is how much extra water do they need? So there are California natives that when they're in a garden setting may need some extra water. Definitely depending on when those gardens are installed. If you've missed the rainy season, then yes, you're going to have to irrigate until we get more weather. And as we are seeing, climate change is making our rain, flood, drought even more volatile than it used to be. So we're going to start out briefly talking about why is spray not as good as drip? Why are we focusing on drip? We start out with the amount of water that is actually delivered, 1 gallon per hour versus 1 gallon per minute. So the amount of water that is delivered in drip is much more slow than spray, which is being delivered very, very quickly. With drip, that water is delivered right to the roots rather than being spread out through the entire garden. Drip means there's also less evaporation compared to spray. And because the water is going only to the plants rather than everywhere, that also helps control the weeds or the grass that grows back. And super important, the reason it is so helpful that that water is being delivered more slowly is that it actually gives the soil a chance to absorb it rather than so much of it running off. So here in this example, I'm going to run my irrigation for an hour. This is per emitter or per spray head. With drip, if I were to run it, one emitter for an hour, I would use 1 gallon. If I were to run spray, one of my spray heads for an hour, I would be using 60 gallons. So imagine I had 10 spray heads. I'm using 600 gallons of water per hour. Now, irrigation isn't just about getting water in there. It really is about getting that balance of oxygen and water in the soil in the proper ratio. So we all know what happens when we don't water enough. So there's a lot of oxygen in the soil, not very much water. But it's also possible that we can have too much water and not enough oxygen. And when that happens, we create what we call anaerobic conditions. And with that, that is where we start to get the pathogens, where we start to get the diseases. So we are looking for that sweet spot. And actually, Brent and I were just talking about that sweet spot where there's just enough water and just enough oxygen. So the first question you're going to ask yourself, and this weekend, if it's nice and warm, you can go out and do a little exploring, is what type of soil do you have? We're going to talk about why that matters. The guidebook that you're going to be getting in a link tomorrow will tell you the different ways that you can test that. So you can test it with your hand, or you can put it in a jar with some water, and there's a little chart that helps tell you what you have. And the reason it matters is because it affects how the water moves through the soil. So not all soils are created equally, and depending on the type of soil, the water moves through it in different ways. And so with sand, you've got big particles, big gaps. The water moves through relatively quickly, and you get sort of a more oblong shape when it comes to the water profile, compared to a heavier soil, a clay soil, if you will, where the particles are smaller, the gaps are smaller, which means that it just takes a lot longer for that water to go down, and as a result, it is spreading out more so. So this is very important when it comes to actually designing your drip system. The next thing you're asking yourself is, well, how much water does my plant need? The way we measure that is through something called evapotranspiration. It is the combination of the amount of water that is lost from the soil and the amount of water that moves through the plant and then travels out, transpires in the form of vapor. And those two things together is how we measure how much water a plant needs. So we look at a range here. You've got turf. Obviously, turf is a high water user. We say it is a high ET plant. So water is moving out of the soil very, very quickly with turf compared to our low and our very low water users, our very low ET water users, which that water is moving out of the soil much more slowly. Key thing to see is that red dashed line there, which is our average rainfall. And so we want to make sure that the plants that we bring into the garden, whether they're natives or not, are climate appropriate, that we are not needing, our plants don't need more water than they get with our average rainfall. All right, getting into the drip system itself. Uh, so it's a little challenging when it comes to irrigation because a lot of it is underground. The controllers in the garage, it comes on at 5 in the morning and we don't really see what's happening. So we thought it would be helpful to have an overview, just briefly, of how the system works. We're going to look at some of the components in a little bit more detail. Water comes in from your water provider, goes through a meter. That is how they bill you. That's how they know how much water you are actually using. From there, that water moves onto your property, and there's two options. In one case, the water goes into the house, and then it goes out into the landscape. The other option is it comes into the property and it splits. Some of that water will go to the house and some of it goes to the landscape directly. And there's no right or wrong, it's just good to know what's happening. From there, there's a couple of things that you want to be aware of. One is pressure, and then the other one is backflow prevention. So we start with pressure. The water comes in from the water provider at a particular pressure. It's measured in pounds per square inch. It can range from, goodness, 75, 100, 200 pounds per square inch. We were actually visiting a client the other day and they were at 300 pounds per square inch PSI. So they had to do a lot of pressure regulating. The other thing to be aware of is something called backflow prevention. So when an irrigation system comes on, the water goes through those PVC pipe, that white pipe gets delivered. And then when the valve turns off, the water will get sucked back into the pipes. And if there isn't some mechanism to prevent that backflow, it can potentially contaminate your potable water. So we want to make sure, and there's different kinds of ways, there's different ways that that water can be, that backflow can be prevented. We're going to show you some examples as well as the most common. From there, we go out to the valves. There is one valve per zone. Each zone, for example, you've got lawn as a zone, you've got edibles as a zone, you've got natives as a zone. You're basically clustering plants with similar needs into one area and then watering them at the same time. And then from there, it goes out. It waters spray, it waters drip, it waters bubblers. So whatever method you are using to deliver that water to the plants. And then the last thing we'd want to point out would be that controller. So your controller might be inside, might be outside. And the important thing about the controller is that you know how to use it, how to read it, how to program it. We're going to talk about that at the end. All right, so here is the pressure regulation I was talking about. On the left are what are called master pressure regulators. They will manage the pressure of everything downstream, whereas regulator at the valves only regulates the pressure at those individual valves. So for example, if you have a combination of spray valves and drip valves, the drip valve will actually have a pressure regulator that lowers the pressure even further than the pressure that is acceptable for a spray valve. If you have questions about that, make sure to ask Brent. He can explain it. All right, so here we have an example of what we call anti-siphon valves. So these are the most common valves. They have this built-in backflow prevention mechanism, and it works with gravity in that the water can't go up high enough to then make its way into the potable system. You will recognize drip valves because of their filter. It looks a little bit like an elephant trunk, and that pressure regulator. One other thing to point out is that when you're working with drip, you want to make sure that you are using low flow valves. Oftentimes they come as a kit, it's already built in, but it is a bigger issue if you are looking to convert from spray to drip. Now here is an example of a drip valve that is actually below grade. So in this, and you can see it has the same elements, right? It's got the filter there and you can see that pressure regulator there. But because it is at grade or even below grade, gravity will not prevent that water from backflowing or flowing backwards into the system. So in that case, you would have what they call a mechanical backflow prevention mechanism. So just something to be aware of. Take a look at where your valves are. Are they above ground? Are they below ground? And if they are below ground, do you have another mechanism in place? Now, moving into the drip conversation specifically, there's two kinds of drip. There is inline, where the emitters are embedded at regular intervals, 12, 18, 24 inches. If you buy a roll, they are all the same distance apart. They are great if you're going to do something called a grid pattern. So that is that photo on the lower right hand, where they are set up at regular distances apart from each other. And they are great when you've got like lots of ground cover or very similar types of plants, where you really want the entire landscape to be pretty consistently wetted. Now, as you are thinking about how you are going to lay it out, here's some other things that you need to think about. So we've talked about the distance between the emitters, but you also need to think about the distance between the actual lines. And it depends on the type of soil you have. So if you have sandy soil, your distances are going to be closer. If you have clay soil, your distances are going to be further apart. And that is because remember how the water moves through the soil, right? With sandy soil, it is a narrower profile. With clay soil, it is a wider profile. And that is why you need to think about how your lines are actually going to be laid out. Another thing, these are tips for installing it correctly. You actually want to offset your emitters. And again, if you were to line up those holes, you would get like rows of watering instead of this much more even coverage. Basically, you're triangulating those emitters so that you get a really nice cohesive wetting pattern. Now, the other type of drip there is called point source or online drip. And that is that you have blank tubing and you punch holes only where the plants are. So in this case, you can see that you've got, plants that are sort of randomly designed, laid out. They're not all clustered together, so there's no reason to be watering those great big blank areas. And so you can see again in the upper left how that tubing is being laid out. Now, a question you may ask yourself, or a question we're going to answer, is how many emitters do you need? And there are variables. So this is an art and science. Typically, we recommend 2 emitters per plant, just as a fail-safe in case one of them gets clogged. The amount of emitters will depend on the soil, depend on the slope, depend on the root depth. But what we've given you here are, some guidelines, some suggestions. Really important is where you place those emitters. So when you are putting in a brand new plant, the roots are small. So make sure the emitters are close enough to the plant, but not right on top of the plant because you don't want to be watering right at where that plant meets the soil. Properly installing your drip system. So the water, when we saw that initial irrigation diagram, moves through those underground pipes, the PVC. We call them laterals, and they will take the water throughout the garden. But we need to get the water up to the surface, and the way we do that is with a point of connection. And so sometimes you can run the drip underground, but we actually find it to be a little bit easier to have it run above the surface, and then you cover it with mulch. And so you've got the lateral, a riser connects the lateral to that point of connection, which is above ground. And then to that fitting, you're going to go ahead and connect your tubing. Now, as you are installing, some things to consider, give yourself some slack. Tubing is cheap. And if it gets crimped, or if there's a leak that develops, or you have to move the plant. It's so much easier if you have a little extra tubing nearby rather than, having to go out and buy some more because you've run out. So you just give it like an extra roll, keep it on hand, and then if you need it, it is readily available. Here's another one. This one seems like common sense to me, but we literally saw a contractor doing this. Water flows downhill, so it is so much easier if the emitters are placed, if the tubing is placed above the plant, and then it will simply roll down to those plant roots. Now, trees need a little extra care, in part because we want their roots to grow not only wide, but also deep. And so the way we accomplish that is with a series of concentric circles. So when you are putting in a new tree, we want to put that first circle within the root ball, right, where the water can get to the roots. And then we're going to put at least a second one a little further out, 12, maybe 18 inches out, so that we can encourage those roots to start to spread out. Now, if you are taking out your turf, don't forget about your existing trees. Your existing trees, if they've been in turf, are accustomed to being watered 2 and 3 times a week for maybe 5 or 10 minutes. And now, all of a sudden, you're switching over to a different irrigation style and they're going, hey, well, what about me? So it's the same principle, these concentric circles. And the thing that you have to do is those circles have to go out as far as the canopy, because that's where the roots are. That's where they are looking to get their water. So you're going to need a few of those rings. Other things that make your job more successful is every 3 to 5 feet on drip tubing, you're going to put in staples. You want to make sure that they are U-shaped rather than flat or like half a U, because then those just don't stay in very well. We talked about the emitter placement, making sure that it is between the root zone and the stalk or the trunk and not touching the trunk directly. And then covering it with mulch, 3 to 4 inches of mulch. If we don't, if that tubing is exposed to the sun, it will start to deteriorate. And then when it does, it will eventually crack and leak. Now, this is really cool. I remember when drip came out and you would turn it on and then you'd put your ear to the valve to go, is it working? Is it working? It's like that. Are we there yet? And they developed these little items called tattletales. And so you attach a tattletale to each valve at the furthest point of it. And when the valve comes on, when it starts watering a particular zone, that tattletale will pop up. And that indicates that the line is pressurized, that it's working, that there are no leaks. It is a clue for when things go wrong. And then when the valve turns off, it sinks back down to the ground, so it is invisible. Flush valves. This allows you to flush that water out. We'll talk about a maintenance schedule, but you will get a little bit of sediment that starts to build up. So the cleaner the inside is, the more your irrigation system will work. What to avoid? Spaghetti tubing. So the spaghetti tubing is very fragile. It is easily broken. That little green knob never works appropriately, so don't go there. Maybe in pots. I think that was actually one of the questions someone asked. But yeah, otherwise just stay with that 1/2 inch tubing. We talked about how important it was that the emitter be close enough to the plant to actually do it some good, especially when they are brand new. Their roots just don't go out that far. And then the last one is to make sure that the tubing is touching the ground, because even though it's called drip tubing, it's not like a faucet. It's not going drip, 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 drip. The water will come out, especially if it is a 0.5 gallons per hour, maybe even a 1 gallon per hour. That water isn't coming out very quickly. And so it will actually run along the tubing rather than dripping down. And so it won't actually get to the ground until it is touching it. 4, Converting spray to drip. So there are these drip conversion kits that are offered as an easy solution to convert spray to drip. But there are things that you're going to want to consider because it's not really as simple as you would think, or you certainly have to be aware. Some of the things you need to look at is how old is your system? We honestly say if your irrigation system is older than 5 years, or you're not quite sure how it went into the ground, you should consider replacing it. In this case, this irrigation system is probably as old as the house, or very nearly so. The next thing is, what is the condition of the valves? So we said for drip that you need these low flow valves, right? Because what was happening in the beginning is when you went from spray to drip and you didn't change the sensitivity of the valve, then the valves for drip would just turn on. And because the flow was so light, they didn't know when to turn off. So if you have older valves, you will need to convert to low flow drip valves. Can you save the existing pipe? This is one that we would love to say yes to. And so even underground, the pipe will begin to degrade. Sometimes there was a break or a problem and the lines were sort of jerry-rigged together. It's also quite possible, in fact, very likely that the hydrozoning is a little bit weird. So you've got pipe that's watering grass and it's watering shrubs. So they shouldn't even be on the same hydrozone. So there you go, that too. And then as you saw with those drip kits, the way they work is that with the newer spray heads, you can unscrew what we call the guts of them and then put in the drip conversion kit and you're good to go. But with these older brass heads, there is nothing to unscrew. There's nothing you can put that drip conversion into. So as much as we wish we could make irrigation simple for you, it is actually rather complicated. So how much time does my irrigation need to run? And oftentimes it feels a little bit like people are just pulling a number out of a hat. Now, if you are a landscape professional and you've been doing it for years and years and years, then yes, you know, give or take, how much water is needed. But for most of us, we need a little help. So one of the questions we want to ask yourself is, well, when do we actually need to add the water? And we have this analogy here of the gas tank. So if you're driving your car and you see that your gas tank is almost empty, you really don't want to let it get that low, right? That's not a safe place to be. On the other hand, it's not like you're going to the gas station every day, in order to make sure that it stays full. So really what we are looking at is about the halfway point. We want the water to evapotranspire at about 50%. And that is when we want to replace that water. So here we have a plant, and you can see that every day a little bit more water evapotranspires. And depending on when the plants were planted, how long they have been established, we're looking at between 30 and 50% before you replace the water that has been lost. And so we're going to need to ask these basic questions. What type of soil do you have? Because the water evapotranspires from different soils at different rates. What types of plants are you watering? Is it a high water lawn, low water shrub? And then you have a slope because water moves more quickly when it's moving downhill. So that too will affect your schedule. And then of course, sun or shade. If it's out in the blazing sun, that water is evapotranspiring more quickly than it is in the shade. Now, They have made things much easier for you in Monterey County in that there is a watering calculator. So you can go ahead, put in your information, all the information we've been talking about, and it will go ahead and provide you with a schedule. Now, that being said, you need to, let's see, do I have it? I do. So here is a sample. You need to make sure that you are adhering to local water restrictions. So if we move into drought, obviously that supersedes the schedule that is provided by your municipality or your water provider. That will supersede this chart. But this is a great place to start. And we'll be sending you a link for that. Once you get your information, write it down on a piece of paper and put it with your timer so that, a year later, you're not going, oh gosh, what did we come up with for that? And then we'd actually recommend that you map it out. So turn on your irrigation system, turn on all the valves and see what gets watered with it. Where's your controller? Do you have a pressure regulator? Do you have a backflow prevention mechanism? It's really good to know what you have and then put that with the controller as well. And now we're going to go ahead and actually program one together. And there's different companies, different models, different makes, but they all work. These are manual controllers. They all work essentially the same. They may call some of the terms something a little bit different, but the principles are going to be the same. So we are going to imagine that we're all working on this one manual controller with one station. We're going to keep it simple. Since this is a drip class, we're going to go ahead and irrigate with a drip system. What we've got are low water use shrubs with drip, soiled as a clay loam, and it is out in full sun. On this controller, here are the different buttons, knobs, etc. We've got run, and that is super important because when you have done all your programming, you want to set it to run so that it actually knows to begin. The control buttons, those are the arrows, the pluses and minuses. That is how you will move through the different menus. There is a program button. We're going to come back to that one a little bit later. And then we start with the knob. So the first thing is date and time. You need to make sure that that is correct, that that is accurate. Then start time is when will the irrigation begin. Runtime is how long will it water, and then water days is it watering every other day, is it watering once a week, etc. Coming around, we've got seasonal adjustment. I'm going to save that one for a little bit later as well. Running the irrigation manually means that just that, if you're checking what is happening with your irrigation system, you can run it manually. Rain sensor, pretty self-explanatory, making sure it's on so that when we do get rain, that your irrigation system turns off. And then, of course, the on and off for the controller itself. So we're going to start out with the date and time. Again, everything will be based on that. So if you didn't adjust it for daylight savings, then it could skew things for you a little bit. And you use those arrows and pluses and minuses to move through the calendar and the clock. Then as far as setting it, again, it's going to depend on your area, typically anywhere between 6 p.m. and 6 a.m., maybe later, maybe earlier. And then the thing to know about the start time is that once you've set the first one, if you had more than one zone, say we had 3 zones, each one would turn on sequentially. So you don't need a start time for each of the valves, you just need a start time for the first one. Next, setting the runtime. So that is where you're going to use that calculator, that watering calculator. It's going to tell you what you need, and then you go ahead and turn the knob to that button, and then you use plus and minus to adjust that amount. And then finally, the watering days. So it could be days of the week. In some cases during the drought, it was like, Mondays and Thursdays. Maybe it's once a week, maybe once every 2 weeks. That is where you put that information. And then you take it back up to run. Make sure you take it back up to run or auto. And then away you go. So we say that was easy. But what if, which is often the case, that you don't have just one zone, you actually have multiple hydrozones. So this garden actually has a lot more than the two, but we thought for this class, we again would keep it kind of simple. We've got two. We've got lawn and we've got natives. So each valve, we now have more than one, needs its own station and its own schedule, which is when we will start working with programs. So someone once said to me that programs was a lot like working with mini timers, mini controllers. It allows you to group the zones together that have similar watering needs or irrigation types. So all of our valves that are running drip would be on one program. All the valves that are running spray would be on a different program. So for tonight, program A is going to be our drip, our natives. Program B, zone 2, is going to be our lawn watered with spray. Let's see what we do differently. So we've already got our date and time. That was, we set that up. And now what we're going to do is we're going to use that program button. So there's, depending on the type of controller you have, A, B, C, some of them have a D. So that's 3 or 4 different clusters that you can create. So I'm going to go to program A. Program A was my drip, and I'm going to enter the start time. And then I go to program B and I enter in a different start time. So this is where it differs. When we had just one program, all my valves ran consecutively. When I have different programs, I actually have to set the start time for each of those. So here's an example. Program A, my drip, it's going to run for 45 minutes. I'm going to start it at 4 in the morning. Program B is my spray. I'm going to start that at 5 in the morning. So 45 minutes it runs, it rests for 15 minutes, and then my spray comes on. What you need to be careful about is that they don't overlap. So if I was running my drip for an hour and 15 minutes, and it didn't end until 5:15, but I had set my spray to start at 5, I would have a 15-minute overlap. And when you do that, your controller doesn't know what to do, and so it doesn't function properly. So make sure that your programs have enough space between them so that things can run without overlapping. Something else you're going to want to think about is cycle and soak, especially if you have lawn area, especially if you have spray. What will happen is it will water, and then at a certain point, the soil isn't able to absorb that water and it will start running off. So this is where we waste so much water. So what we do instead is we run it, the cycle, and then we stop running it for maybe 60 minutes, and then we run it again. That 60 minutes gives the soil the opportunity to absorb that water to soak in, and then that way all of the water that was applied actually gets into the ground. All right, coming back to our programming. So we set the time for 5 a.m. and then we're going to keep going around each of the items. So now I'm going to put in my runtime. I believe that was 45 minutes. Again, you're going to use those pluses and minuses. And then I would go around to the third one, the watering days. And for drip, maybe I'm watering once a week or once every 2 weeks. And then I go back, I hit that program button, and it changes it to B. And I do the same thing. I'm going to set the runtime since it's lawn. Maybe I'm watering for 5 minutes. I'm watering every other day or every 3 days. And then I can go ahead and take it up to run. So for those of you that are not familiar with the controller, that might have felt a little bit overwhelming. If you have questions, please ask Brent. I know especially, for me, when I was learning that whole concept of the programs and start times was a little bit confusing, and it's hard if you don't have the actual machine in front of you. But if you have a manual controller, check it out this weekend and, play with it a little bit. Tonight's class is recorded, so you can go ahead and go back through this part. Now, again, with the irrigation, it is manual. You are having to schedule it yourself. The way it works is we set the clock for what we would call peak watering. So that's June, July, August, when the plants will require the most water. And then you go to seasonal adjustment and you reduce it for other parts of the year, because we are not watering at the summer schedule all year round, just during those 3 months. And then as the days get shorter, the weather gets cooler, we are going to start turning our irrigation down. Our plants don't need that much water all year round. And then come winter, if we get rain, you are potentially, well, not potentially, if we get rain, you turn off that water. If we don't get rain, you are having to irrigate, because that is when our plants are accustomed to getting their water. Now, you can make life a whole lot easier by getting a smart controller, in which case takes the guesswork out of all of this. It is gathering data from the climate directly, and it is adjusting the timing based on the weather. What they have found is it saves water over the manual controllers. It automatically does the cycle and soak. It can track your water usage, so you can compare 1 month to the other, 1 year to the other. What else? And it automatically shuts off during the rain. Depending where you are, there are rebates available for smart controllers. Now, as far as getting information about weather conditions, there are local little mini weather stations that you can put in your garden, but most of them now are running off of satellites, and most of them can be programmed directly from your phone. So if you're on vacation, you're at work, you can go ahead and just do it right from there. Now, as far as programming it, way easier. You start by putting in your address. This lets it know where you are, what your climate is. You name your zone, so it's lawn and it's shady natives and it's sunny natives and it's edibles. And then you input the conditions, which is just what we did for the manual. So it's the same information. They just make the second part a little bit easier. So what type of plants do you have? How are you irrigating? What is the soil type? And then what are the watering parameters? Are we watering every other day? Are we watering every 3 days? At some point when your plants get established, you would go ahead and set it so that it is adjusting based on the climate. Now, as far as resources, these are very well, what's the word? Very well described, very well resourced. So there's a paper manual, there's the app, and then of course, 101 YouTube videos. All right, last piece of the puzzle, the maintenance. You have to turn your irrigation system on. As we said, it goes on at 5 in the morning. You don't know what is happening. So at least quarterly, turn it on. It's easy to do it at the beginning of each season, right? Summer, winter, spring, fall. You're looking for leaks. You're checking the moisture in the soil. Are the emitters still where they're supposed to be? And if it's a manual controller, you are making adjustments. Getting a soil probe lets you see what is below the surface, lets you see where the moisture is, lets you see potential layers of soil, lets you see those roots. Maybe you want to get a soil moisture sensor. So you can put that into the soil, and then there's a gauge that says, is it too wet, too dry? And then being aware that it is quite possible that the surface looks dry, looks wet, and that when you go below, it's actually parched. This soil is actually so dry that the water is not making its way into the soil. So, you're out there with your hose or your irrigation's been running. Every now and then, check and go, is that water actually getting where it is supposed to? Now, we talked about little plants and where those emitters need to be. It's not just the roots, it's also the soil, which is very, very porous, so the water goes through it quickly. Um, and then when the plants get more established, the roots are obviously going deeper. They have made their way into the native soils, so you can start cutting back. And potentially, assuming we get our winter rains, you can turn off the irrigation completely. Now, signs of trouble. You see something like this, it's possible to assume that it is a gopher, but it's just as likely it is a shovel. This is obviously a bad sign, but don't just assume that it didn't get enough water because the symptoms are very similar. It's quite possible it got too much water. And then if you see something like this with puddles or standing water, there is a leak someplace. Maybe it's the drip tubing, but it could also be a point of connection. It could also be a lateral. So you do have to do a little bit of sleuthing. Turn on the valve, see if your tattletale comes up. It helps with the detective work. And then basically you're just checking the entire irrigation system to see where the problem might be. It's also quite possible that your irrigation timer, something has happened to that. If there was a power outage, sometimes even with a battery, they will reset to the factory settings. Now, one of the great things about leaks with drip tubing is they're so much easier to fix. You don't have to dig anything up, right? This is primarily why we keep it above the surface. So if you put a hole into it by accident, you might, oops, that's in the wrong place. There's a goof plug, so you can fill it back up. And if there is a leak or a crimp, you can just cut it on either side. And then there are these couplings that you can just put it back together again. Even I could do it. That filter is there for a reason. It does need to be cleaned out at least a couple of times a year. Really easy to do. Again, you simply unscrew it, pull out the filter, rinse it off, and then put it back in. You want to use that flush valve again, so you can flush out the tubing. Do that maybe a couple of times or 4 times a year. And making sure that when that water is being flushed, that it stays on site, that it's not being flushed out onto a sidewalk or any hardscape. And then make sure that the tubing stays covered. So when we install a new garden, typically we're putting in 3 to 4 inches of mulch, but how often have you walked by a space and there's the drip tubing completely exposed? So the mulch is good for the garden and it's also good for the tubing so that it doesn't deteriorate. Now, you may have issues with your timer. For example, there's nothing there, a blank display. Odds are it's something that happened with the power. So you can either unplug it, replug it, and then hit the on button. It may come on, or there's a reset button that may bring it back up as well. If it's not working, make sure it has been set to run, set to auto. This one happens all the time. Make sure that each valve has actually been properly programmed. Sometimes what will happen is you start and you don't actually finish. So the controller doesn't know what to do with that. And then confirm what your schedule actually is. For the smart controller, something that often happens is the Wi-Fi goes out. And you want to make sure that you've got a strong signal. If not, you want to get some sort of extender or make sure that you put it in a place where it has easy access to the Wi-Fi. Otherwise, it will not be able to connect to the satellite for that information. If it goes out, similar to what happens with your router, you want to go ahead and unplug it, let it sit for 30 seconds or a minute, and then reset it. When in doubt, hire a professional. Irrigation is really one of those places where, unless you're handy, this is a place to bring in someone who knows what they are doing. There are, potential issues with leaks, potential issues with floods. Your plants can die. So if you're getting a rebate, for example, and the question is, well, where do I invest my money? It may be that you want to invest it in your irrigation professional. All right. Now, there is a great website to help you with all of this work that you are doing. The Monterey Water Conservation website. You will be getting a link to that in the email that goes out to you tomorrow. There's great resources that are available to you and rebates. One of them includes this tree watering ring, where this only works really for new trees, doesn't work for the more established ones, where that water can be released slowly to the plants. As far as rebates and resources, there is a Cash for Grass program. There's an audit where they will actually come out to your property and tell you what is going on, help you with scheduling your controller, rebates on the controllers, rebates on the soil moisture sensors. If you're interested in cisterns, there's rebates for that, as well as a rainwater class that we're doing later this year, and then those tree rings. All right, Brent, I think we got some questions.
Yeah, I was a little bit busy. It was good.
Good, 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 good. So anything, what do you wanna, what do we want to tell folks?
What do we want to highlight? Okay. Um, with drip tubing, don't try and duct tape it back together.
Oh
Just
my goodness. Okay.
um, there's a little conversation about flex tape and its effectiveness and duct tape, and honestly, for the cost of drip tubing and couplers, just cut the section out, couple it back together. It's inconvenient, but that is your option. Behind the
And then I
scenes.
guess, yeah, just from your point of view as an what are common problems, or what would you, if there were a couple of takeaways that you would want people to make sure that they walked away from, what would you want?
Let's Okay. So a couple things with drip systems is we have to switch our mindsets from if you're used to watering with the spray system, it's like 4 minutes. If you get real adventurous, people do 10. You'd be totally outlandish to do 20. And when we start talking drip systems, we're talking in gallons per hour, and 20 minutes is like not enough water. So, especially if you have established shrubs or large shrubs, it's not crazy to think of a 2 hour runtime.
Right.
Even,
But you're not running every day,
yeah.
right? It's two
Um,
hours
but
every,
we're gallons per hour, not gallons per minute.
yeah.
Um, it's a lot. That's a difficult thing. I see a lot of people that can conceptually get that drip is more efficient, but then don't quite make the leap to, even though you're running more minutes, you're still using less water.
Yeah, but at 2 hours, we're not watering every other day. We're watering maybe once every 3 weeks or once a month. It's a very, especially when we're looking at these climate appropriate or native plants, it really is a different way of looking at the schedule.
The other thing is that this is true for all irrigation. Nothing can replace a human being there and looking at the irrigation. The most sophisticated flow sensors, even if it was sensitive enough to tell you if an emitter had popped off, can never tell you if an emitter got moved and is now no longer watering your plant. If, you know, a coyote came and dragged your drip line 10 feet away from your plant, it somehow didn't puncture it, but no flow sensor is going to tell you that that plant is no longer getting water. So nothing can replace you being out, run the system, look and listen, and that, yeah, is irreplaceable, no matter what kind of system you have.
Great. So it looks like there are a couple things that came in. Are there, I'm going to stop sharing actually.
Uh,
Um,
let's see. The latest one is we're establishing a new garden into a blank slate and don't yet know where plants are going to be. We should not plan to use the spaghetti tubes off the main tubes when we plant our new plants. That is correct, James. You should not. Ideally, you wait until you have the plants in the ground and then you'll run that 1/2 inch or 5/8 tubing to all the individual plants. And if it's a really dense planting, then you would use the inline tubing and you just make a grid.
see, the questions are coming in now, aren't they?
Yeah. Do you recommend getting a water sensor? what kind of water sensor, Dana? Because there are lots of different sensors that you kind of classify as a water sensor. I have all my edibles in containers, so I have very dry episodes. Need to learn how to use a drip system in my containers. Okay, so containers are, there's no way around it. There's just not a very large soil reservoir, so you do need to water more frequently.
Yeah.
This is going to be kind of a minimum twice a week with containers.
Yeah. And especially the soil is different if you're using a potting soil. It's way more porous, so the water's moving through it more quickly. It dries out more quickly. And in some cases, if it doesn't get watered enough, it dries out so much that it becomes hydrophobic. So you water and water and water, and the soil doesn't actually hold on to the water. It doesn't, it's no longer, you're no longer watering your plants. So yeah, containers are you got to be on top of them.
Let's see what else we one that has a long end and a dashboard gauge to show the moisture of the soil. Oh, I know what you're talking about. I don't use them professionally, but I have seen plenty of homeowners use them. I think it's something that if you can correlate what you're seeing on the gauge to what you're seeing in the plant, it's a useful tool. And it can be, for example, too much water and too little water often show up the same, because when it's too little water, it's too little water. When it's too much water, there's not enough oxygen in the soil, so the water can't flow into the plant. So it's also kind of too little water. So in something really difficult like that, one of those soil moisture sensors, you can correlate what you're seeing with what's going on. So that, in my opinion, is how they can be useful. If your soil becomes hydrophobic, how can you fix it? If it's in a pot, you dunk the pot in a thing of water and you force it to become hydrophilic. If your soil in ground is hydrophobic, you've got a little bit of work ahead of you. You've got to add some organic matter and yeah. I'll leave it simply that you need to add organic matter.
Yeah.
Fluid reports using too much water. Where is my leak?
Wow.
I can help you.
Yes.
Joe?
Yes, is Mr. Butler, if you're a California American Water customer, I could have one of my people meet with you. If you're one of our customers. Otherwise, if you're using too much water, then you're going to have to go through the process of elimination. Maybe you have a toilet leaking, maybe your irrigation controller is going on too frequently, maybe you have an intermittent toilet leak. It could be a variety of different things, but we can, a CalAm, we can help.
Great. Yeah, you guys have great customer service. So, all right. Well, thank you so much for joining us. Happy gardening and have a great weekend. Bye-bye, Joe. Thank you.
Edit that
Thank
out.
you, folks. So
I'll get
wonderful to have you.